In your previous class, you would have learned about finding or proving similar triangles, finding the scale factor k, finding the missing sides of a triangle, as well as using the area of one triangle to find the area of the other. Now in today's class, we're going to look at calculating the scale factor, proving that triangles are similar, finding the length of the missing sides, as well as the area of the triangle. Now, we have our first question on the board. So given that triangle ABC, we have AB equals 4 centimeters, AC equals 5 centimeters, BC equals 3 centimeters. Now we're given all the lengths of the small triangle, which is triangle ABC. We are now being asked to find, or rather, prove that triangle XYZ is similar to triangle ABC. So in your previous class, we learned about proving that triangles are similar. So in this question that we have on the board, we are given the lengths of triangle ABC, which are AB 4 centimeters, AC 5 centimeters, BC 3 centimeters. And let's look at triangle XYZ. We're only given the length of side XZ. Now the first question we're asked is to prove that triangle XYZ is similar to triangle ABC. Now to do that, we're going to recall from our first class that similar triangles, for them to be proven similar, we have to look at the angles. Now if the angles correspond to each other in both triangles, then we can say they're similar. So let's look at both triangles. We can see that angle A here is equal to angle X, so we're going to state that. So angle A is equal to angle X. Also, we see that angle B is equal or corresponds with angle Z, that's a 90-degree angle. As well as angle C corresponds with angle Y. And we can know that based on the strokes that are given for each. Alright? So we can state that, therefore, triangle XYZ is similar to triangle ABC because all angles correspond with each other in both triangles. Okay, now that's our proving similar triangles. Our next question here says, calculate the scale factor K. Now, how do we find the scale factor K? Remember in our previous class, we looked at the sides of the triangle that correspond with each other. Now, looking at both of these triangles, we see that we're only given the length of XZ for the bigger triangle. Now, which side corresponds to XZ of triangle ABC? We see that side AB corresponds with XZ. So we're going to use those two sides and find K. Now we have to divide the bigger side by the smaller side. So K is going to be equal to XZ over AB, which is equal to 8 centimeters divided by 4 centimeters, and we get K to be equal to 2. Alright, so now that we have found our scale factor, we're asked to determine the length of YZ and XY. Those are the missing sides of triangle XYZ. Now to do that, we have to use a scale factor, because this scale factor tells us that triangle XYZ is 2 times bigger than triangle ABC. So to find YZ, we're going to look at the side of ABC that corresponds, and that side BC. So YZ is going to be equal to K multiplied by side BC. K, as we know, it is 2. The length of BC is 3 centimeters. So 2 multiplied by 3, that gives us 6 centimeters for side YZ. So we're going to put that in. Alright? Next, we're asked to find the length of side XY. Now, which side does XY correspond with? In triangle ABC, and that is side AC. So again, we're going to use the scale factor K multiplied by AC And that's going to be 2 multiplied by the length of AC, which is 5 centimeters. And we get 10 centimeters. Alright, let me just put that in. Alright, now you've noticed that we have found the 2 missing sides of triangle XYZ. So part D of the question is asking us to find the area of triangle XYZ, given that the area of triangle ABC is 6 centimeters squared. Now to find that, area of triangle XYZ is going to be equal to K squared times the area of triangle ABC. So previously we found K to be 2, so that's 2 squared multiplied by the area of triangle ABC, which is 6 centimeters squared. Now when we square 2, we get 4. That's 2 times 2. 4 multiplied by 6 centimeters squared, and that gives us 24 centimeters squared. Now that is it for the area of the triangle. Alright, let's just go through one more time. And then to my right, you have 2 questions that you are going to do on your own. Alright, so let's just recap what we just did. So to prove that the triangles are similar, we have to look at the corresponding angles. Now if all angles in both triangles correspond, then we can state that triangle XYZ is similar to triangle ABC. To find the scale factor K, we're going to look at the sides of the triangles that correspond. Now, in the initial stage, we were given the length of XZ from triangle XYZ, and so we use that length and the side that corresponds to find the scale factor K. So it would have been 8 centimeters divided by 4 centimeters. We got our scale factor to be 2. To find the length, we use the scale factor, multiply it by the corresponding sides for YZ and XY. So YZ would have been 6 centimeters and XY we found it to be 10 centimeters. And remember, for the area of the larger triangle, we're going to multiply the area of the smaller triangle by the square of the scale factor K. And in this case, our answer would have given us 24 centimeters squared. Now, to our right. So you're given 2 questions. Please look at them carefully. For the first one, it says prove that triangle PQR is similar to triangle ABC. You're given the length of all 3 sides of triangle ABC, but you're only given the length of triangle RQ of triangle PQR. You're to calculate the value of K, which is the scale factor. Use that scale factor to determine R centimeters, which is the length of PQ, and Q centimeters, which is the length of PR. As well as use the area of triangle ABC given to determine the area of triangle PQR. And you're going to do the same thing for question 2. Alright, that is it for our class. See you guys in our next video where we look at congruent triangles.